Now let's move on to the second example. Determine whether f of x equals 2x squared plus 11x plus 5 all over x plus 5 is continuous at x equals 0, and the second one is x equals negative 5. We determine first that the function is continuous at x equals 0 by using the three-step method. We evaluate f of 0. We will have 2 times 0 squared plus 11 times 0 plus 5 all over 0 plus 5. Simplifying this, we will have 5 over 5, which is equal to 1. Hence, f of 0 exists. The first condition was satisfied. This time, let's check if the second condition is satisfied by the function. We prove that the limit of the function exists. With that, we have to show that the left-hand limit of the function is equal to the right-hand limit of the function. Hence, we will have the limit of 2x squared plus 11x plus 5 all over x plus 5 as x approaches 0 from the left is equal to the limit of 2x squared plus 11x plus 5 all over x plus 5 as x approaches 0 from the right. Evaluating at x equals 0, we will have 2 times 0 squared plus 11 times 0 plus 5 all over 0 plus 5. At the right side, we will have 2 times 0 squared plus 11 times 0 plus 5 all over 0 plus 5. Simplifying these expressions, we will have 5 over 5 equals 5 over 5. Hence, we can say that the second condition is satisfied. The limit of the given function exists. This time, we check if the function satisfies the third condition. We show that the limit of 2x squared plus 11x plus 5 all over x plus 5 as x approaches 0 is equal to f of 0. In step 2, we found that the limit of the function is equal to 1. And in the first step, f of 0 is equal to 1. Therefore, f of x is continuous at x equals 0. Graphically, we support our answer that it's continuous. This is the point on the graph where x is equal to 0. Okay? Now, if we trace this graph, can pass through this point continuously without lifting our pen. Now, let's try whether the function is continuous x equals negative 5. We again use the three-step method. We evaluate the given function at x equal to negative 5. So 2 times negative 5 plus 11 times negative 5 plus 5 all over negative 5 plus 5. Okay, to simplify this, this will be 2 times 25 minus 55 plus 5 all over 0. Now, in the numerator, we also have 0. So, this is an indeterminate form. Therefore, f of negative 5 does not exist. Therefore, we can say that f of x is discontinuous at x equals negative 5. So let's support our answer using a graph. Okay, so graphically, we can show 2x squared plus 11x plus 5 all over x plus 5 using this line. Now, since we cannot use negative 5 for x, this point will be represented using an unshaded dot or a hole. So, if we will trace this graph, we will be interrupted by this hole in order to continue tracing the graph. Therefore, we can say that f of x is not continuous at x equal to negative 5.